So this video, let's talk about this integration. Okay, so before I start, I hope you guys subscribe to my channel, and I want to introduce. Okay, so not this. So I want to introduce that if you want to see more calculus video, you can go to my video Math Geeks, and you'll find this playlist that I will leave the link below. There's a reduction formula in the calculus. So basically, there are a lot of reduction formula. If you're interested, you can check out. Okay, and also there are a lot of another video list called integral of trigonometric functions, and there are a lot of like sine n, tangent n, cosine n, secant n. There are a lot of reduction formula. Basically, are famous ask. It's sometimes asked in the calculus test or homework. So if you want to see a so-called step-by-step computation, then you should go to my playlist. And I will also leave many other lists if you are interested in other mathematics like group theory, real analysis, or even algebraic geometry, which is very crazy. I mean, I don't care. Okay, so now this is a new series that I want to deal with some integral with the there are the square roots. Okay, so yeah, so let's start. Okay, so every time you see a square root, especially x squared plus 1, the idea is that you want to let x equals to tangent u, right? Because you know that if you know that the tangent squared plus 1 it will be second, right? So once you have this, then you can open the so-called open the square roots. Okay, so x squared plus 1 will be second u, and dx will be second square u, right? So since that the tangent will be second square, sorry, du. The tangent differentiation will be second square. Okay, so let's see. The original integral become what? Become second u, second square u du. So it's a second cube u. Okay, and you can see my other video to compute this. But let's quickly compute by the so-called integration by parts. So I can use this to be. I can write this original one to be let's say second u d tangent u, right? So it's the same. Okay, so that means let me see. So that means actually we can solve this by other method. Oh, okay, that's fine. So second d tangent u, right? So that means I can write as second u tangent u minus second u fixed. Sorry, the tangent u fixed. This tangent u will fix, and the second u differentiation, which is the second tangent. Okay. So this term will be second tangent minus second square minus 1 second du. So it's second tangent. So let me just write quickly. Minus second cube du plus second u du. Okay, so this guy is a second to a cube u du, right? So you have this. And if you see carefully, then you know the answer will be second u3 cube u. You can combine these two. So you get half second u plus second u tangent u plus the integration of second, which is a famous long second plus tangent. And there is a half. Okay. So, but this is not answer, right? Since that there's no u. So originally we defined x equals to tangent u. So let's write down the answer will be, so the integration of x squared dx will be half plus x squared plus 1 is tangent. And second, and for tangent, which is x, plus a half long second is a square root of x plus 1. Tangent will be x, right? So yeah, help you. Okay, so very funny. This is the answer. Okay. Okay, so let's maybe check out. Maybe we can use a method 2. Okay. So the method 2 is similar to the method 1, but without a trigonometric idea. So one idea is that we use integration by parts with this dx. So this is a square root of x plus 1 x minus x, and the differentiation in respect to this. So it's a square root of x plus 1 2x dx. Sorry, because your differentiation there's no 2 here, right? So you can write this as x square root of x plus 1 minus x squared divided x squared plus 1 dx, right? So this so this term, right, looks similar. Okay, so right, so in order to give the same thing, if you see these two, right, then the idea is that you need to somehow like try to solve this, right? But it's still, but I mean it's the same that if you use the, okay, so let's see. If you define x to be, I mean it's the same, right? If you define, let's see, if you define x to be tangent u, then this thing is a tangent square, second, and the tangent divergence is second square, right? So, and then, I mean if you do the same thing, then you will get the same results. Yeah, so I mean it looks like that if you just want to use the integration by parts, then the okay. So I know. Let's see. We can write x squared plus 1 minus, let's say I add x. So I add x plus 1 square root of x plus 1 dx. And then this is minus 1. So I add this. Okay, so I believe that this integral is easy to do, right? So you get this. And then for this one, you get square root of x plus 1 dx, right? So this is the same as previous plus this. And this is equals to this. Okay, so you see these two terms are the same. So finally, you get a square root of x plus 1 dx, which is a half x. Okay, so the remaining is that you just try to do this integration. And this is very easy as an exercise, right? Because now square root is in denominator, right? So if you define x to be tangent u, then you are easily get a 1 second term. And then you get 1 second, then you can easily change the second to be long x plus tangent. So this is done. Okay, so this tells you that you can also, without use triangle substitution in the final step, you can still get the answer. Okay, see you guys next videos. Hope you guys subscribe.